All right, in this last example, we're looking at group H. So we've got our first 32 integers over star. Star is addition mod 32. And we're proving that for the subset G4, which is the multiples of 4 in H, prove that that is a subgroup of H under addition mod 4. So we've got G4. Let's think of what G4 is. G4 is going to be our multiples of 4. So I keep messing up my left bracket. All right, 0, 4, 8, 12, 16, 20, 24, 28. And of course, 32 is not in this group. It starts at 0, ends with 31. So there's our group 4. So if we're going to be a subgroup, we need to have an identity element. The identity element is going to be 0. So E is equal to 0, and 0 is an element of G4. So that's great. We need our group to be closed. So if we're going to think of this with addition mod 32, any two of these that I add together, you need to ask yourself, if it's closed, am I going to get back another one of these? Well, since they're all a multiple of 4, and since 4 is a factor of 32, any of these that we add together are going to give us back an element that's inside of G4. So our group is closed. So we're closed under addition mod 32. All right. We need our inverses. So for any of these, we need values that are going to give us back 0. Well, since we've said it's closed and we've got mod 32, we're going to end up with elements that are going to give us back 0. And more specifically, our inverse elements. So for 0, the inverse is 0. But then for any other element, G, in G4, the inverse is going to be 32 minus G. And of course, this is G, element of G4, but excluding 0, because we've said that 0 is self-inverse. So let's make sure that we exclude 0. All right. So we've got inverses for every element. It's closed, and we know that addition is associative. Addition is associative. Therefore, G4 is a subgroup of H. And more specifically, it's a proper subgroup. It's not trivial. All right.